So now that we've covered the long division, I wanted to come back and just address something that has occurred in other chapters in this class that does show up with long division. And that is that this remainder, and keep in mind that we're dividing by this. So another way of thinking about this is that this is the denominator, and it shows up on the remainder. It produces a domain restriction. So remember that domain restrictions are where the denominator, right, the denominator cannot equal 0 in any problem. So if I set x minus 2 not equal to 0 and solve that, I will see that this problem has a domain restriction that x can never equal 2. I like to think of those as anti-solutions or anti-roots. You know, you do this zero product property quite frequently to find solutions, but this is finding where a solution is impossible. Meaning this is my answer, but if I put 2 in here, I'd have 5 over 0, which would make it undefined. So each of these problems has one. I'm going to go back through now and take a look at each of the domain restrictions for each problem. So this one that we did here, the domain restriction would be that this denominator right here, or it's actually the divisor, keep in mind that the divisor is the denominator, is that x plus 3 can never equal 0, because that's the denominator of the remainder or the divisor. So I would subtract 3, and then something interesting happens here for the first time for domain restrictions, but it happened in our quadratic chapter, that you end up taking the square root, and you end up getting that the domain restrictions are imaginary. And what that is telling you is that you actually don't have any, because right from the quadratics chapter, this would come out to plus or minus the square root of I root 3. So I don't actually need to include any domain restrictions on this problem because they're imaginary. And imaginary domain restrictions would not cause an actual problem in the set of real numbers, which is what you reduce algebraic expressions over. So this would be the answer. And this would have a domain. Remember, the domain refers to the xy axis, and so there would be no interruptions on this xy axis with this. This does not show up here, so this would be the answer with no domain problems. So when we look at this problem was the same as the one we looked at earlier. Literally, it's the same problem. So x could not equal 2. This one, you would have that x plus 1 could not equal 0, so x can never equal -1 here. So I just put a little semicolon and say this is my answer, but x can never equal -1. And then for my last one here that we did, that we had to divide, remember we had to do that division because of this little rule that says if you have a coefficient that is not 1, you have to divide by that coefficient at the end. There's a mix match, of course, that can't be fixed. This one doesn't. This one's interesting because it appears to not have any domain restrictions. The domain restriction is still that x could not equal -1/2. Now, why is that? Because the divisor, even though there was no remainder, because we divided by this, this is still a denominator. So that domain restriction is still applicable. And so notice that when you do synthetic division, the domain restriction is actually the same as the number you have out here every time. So that number is what you use with synthetic division, but it also is the domain restriction because it comes from the divisor. Now this problem here we didn't end up doing because it was long division, but it is the same problem we looked at here. I just copied it. And that one is the whole situation that we have where we have an imaginary domain restriction, so it doesn't affect the problem. Domain restrictions are important. They come up in a lot of chapters, and eventually there's a chapter where it comes up in every problem. So please make sure you look through that, maybe watch this part again, and make sure you understand how domain restrictions work for division.